Hello, everyone. My name is Dr. Christine Paszko, and today we're going to be talking about leveraging LIMS to facilitate quality. Now, LIMS stands for a Laboratory Information Management System, and it has many features and functions, everything from sample tracking to viewing sample status to data entry, either manually or by, uploading data from instrumentation. Being able to have peer review so that the person that enters the results is not the same person that validates the results, enforcing data integrity, having basically a given number of placeholders for results to be imported or entered into, and also managing other things in the laboratory that contribute to quality, such as employee training records, instrument maintenance, calibration, repair records, the ability to link standard operating procedures into the system and control those SOPs, as well as keeping track of the chemicals and reagents and supplies that are in the laboratory. So there's so many functions that a laboratory is responsible for, and the LIMS is a software solution that allows a laboratory to best utilize their resources in terms of time spent on tracing and tracking all of those variables. Our learning objectives for today are going to be to understand the role that a LIMS plays in the quality management system. We're also going to learn about all the other systems, enterprise systems, that can effectively integrate with the LIMS to accelerate the time savings, the cost savings, and provide enhanced data integrity, while also providing regulatory compliance. And we're also going to become familiar with the key features of the LIMS as well. What is a quality management system? A QMS is basically defined as a system that documents all of the processes, procedures, responsibilities in the organization for achieving their policies and objectives. It really works to coordinate and direct the organization's activities toward ISO, which is the International Standards Organization. And it has a very large component of customer satisfaction in there, as well as meeting regulatory requirements and also helping an organization to become more efficient, more effective, and to generate high quality data. And it's often a process that of continual improvement. It's not just a one-time process. You're continually, especially in the laboratory, looking for ways that you can boost productivity, cut cost, become more efficient, and also decrease the time it takes to analyze samples and provide results to your clients. What are the primary benefits of a quality management system, or QMS? Well, the primary benefits are basically improved customer satisfaction, confidence in the quality of the data and services and products that the customer is receiving from that organization, and also that leads to trust in that organization as well as repeat business, and it really helps to facilitate standardization. And it goes back to having a consistent experience for the customer. I'm sure many of you have tried, fast food establishments where you had drive-throughs and you've had inconsistent experiences. So you know what a really good experience should look like, as well as one that's not so good. So, the same is true for a laboratory. So you want to make sure that the data that you're delivering is of high quality. You're doing it in the most efficient, effective, and cost-effective way. And you're also able to answer clients' questions or concerns so that they have a good feeling about doing business with that laboratory. And again, it leads to repeat business. Another advantage or benefit of a quality management system is meeting the regulatory compliance goals. With ISO 17025, there's many different goals to be met. And with the help of a quality management system, it has controls in place to ensure that quality is integral to the workload, and also the training records are kept of the analysts. So there's a lot of features and functions to ensure that quality exists in the culture of that laboratory. Now, there are also numerous benefits of the QMS for the laboratory. First of all, document control. Defining, documenting standard operating procedures, controlling them, controlling processes. Also, it's standardization. It really enforces standardization across the organization because everyone's basically looking at the same standard operating procedure and following it. And you're also looking for ways to minimize risks. So if you do have a situation where a mistake is made, you can hold a meeting and take a look at the root cause, and then once that's identified, you can alter your procedure, update your SOP, and retrain everyone to make sure that that doesn't happen again. You're always looking for ways to lower your operational costs. You're always looking for ways to automate mundane tasks so that you can use your most valuable resources, your laboratory team members who are really all knowledge workers, most efficiently. And then also identifying opportunities for training. Oftentimes people want to skimp on training. It's one of the best investments because when you have a staff that's fully trained, they can extract much more value out of the systems they're using, whether it's QMS or whether it's a software solution. Training plays a key role. Also looking at ways to reduce waste. And one of the benefits of the QMS is being able to enhance communication across the organization. So instead of having to go from laboratory to laboratory or looking for data in different silos, you have one centralized location where you can access that information. If we take a look at quality systems, they really consist of processes, basically the procedures that are in place for that organization to operate. We look at the technology, whether it's TFS, Team Foundation Server, to check in code, or it's using Outlook for facilitating email communication, or the LIMS or the QMS, or the instrument controller software, storing data in the cloud. It's all that technology that's used to generate, manage, and maintain that data. Then there's the people. These are the highly skilled analysts and managers and finance team members in IT that allow that organization to be successful. And they oftentimes have advanced training and they have skills on various equipment, instrumentation, such as a tandem mass spec or an ICP-MS, to basically manage and maintain that instrument. Finally, there's a culture, organization culture, a culture of quality. It really does come from the top. So if the team can see that the leadership is vested into having high quality products and high quality teams, they're more likely to make that commitment as well, because it really takes a team. It's not something that one person can take on alone. If we look at controls that are in place to promote data integrity, there are many of them. From a validation standpoint, there's IQ, OQ, PQ, which stands for installation qualification to ensure that the software is properly installed. OQ, operational qualification, performance qualification, which is typically carried out by the end users. There's a quality manual that everyone has been trained on and is familiar with. There's a review system in place, peer review, author, reviewer, and approval strategy. There's an SOP that guides this. There's an audit trail, so if results are changed, there's a reason given for the change, along with the date and timestamps. The original result is stored, the date and timestamps of the original result, the analyst that entered it. If it has been changed, the analyst initials of the change, the reasons for the change, as well as the date and timestamps. It's really important to have those controls so that you can ensure that that data is valid. And then also being able to withstand customer audits that come in and look at your SOPs and inspect your quality management system and inspect your LIMS. Active Directory for security. Have a validation package to make sure that the results are accurate, the calculations are all accurate. Microsoft TFS, Teams Foundation Server, to make sure that there's version control and checks for any issues in the software. And this is all under the umbrella of GAMP 5 and 21 CFR Part 11 with electronic signatures. So it really is important to have those controls in place so that you can be confident in the data that that organization is generating. Next, let's take a look at LIMS. LIMS is an acronym for Laboratory Information Management Systems. It's basically a software solution designed to manage all aspects of laboratory operations. And it all begins with sample tracking, accessioning samples, receiving them into the laboratory, and taking custody of those samples. Next, data entry, where results can be entered either manually or, in today's world, probably 90 to 95% of the results come from instrumentation, which is designed to be integratable with LIMS systems so that that data can be moved electronically, and you avoid transcription errors, because at the end of the day, a laboratory wants to make sure that they have high quality data that they're delivering to their customers. Now, scheduling, this is a function that can be used for stability studies, for shelf life studies, for sample collection. It's a feature that allows the analyst to set up projects or programs where the system will send automated reminders of what samples need to be pulled, what tests need to be run. And again, rather than keeping all this information in your head or in Excel or on Post-it notes, this can all be put into the system, and then the system can remind the users what needs to be done when. Instrument integration is a huge advantage of having a LIMS, because again, not only does it save time and money, but it also accelerates the time for final result to be delivered. It just makes sense. So today we don't do LIMS implementations that don't involve instrument integration. Traceability is becoming very important. With ISO 17025, auditors always look for traceability in terms of the reagents, the supplies, and the chemicals that are used in the laboratory. They look at things such as the lot numbers, the expiration dates, what reagents were used with what tests. They look for certificate of analysis reports that were received when reagents were brought in-house, and with a LIMS system you can actually link a copy of those to the reagent or chemical that was logged in for quick and easy access. There's also resource management that keeps track of employee training records, when they're going to expire, what methods they were trained on. You can link copies of training certificates, and when an auditor comes, you have all that information in one central location. And this is also great for performance reviews, because you can quickly see what training was completed throughout the year. Customer relationship management. This deals primarily with complaints against the laboratory. It allows users to track complaints, how they were received. Was it by email? Was it by phone? Who received the complaint? What was the severity of the complaint? How was the complaint handled? How long was the complaint open? What was the resolution? All of that information can be tracked and managed in the system. Finally, configurability and compliance, making sure that everything is configured properly in terms of your tests, your methods, your reporting limits, all that information, or your specifications, everything that makes your laboratory unique and in line with the work that your laboratory is doing. This really helps to facilitate regulatory compliance, for example, for ISO 17025, GMP, or other compliance goals that laboratory is under control for or under control of. Also, report creation. Automated report creation is huge. This is the biggest time saver, I should say one of the biggest time savers of having commercial LIMS systems, because reports can be automated the minute the last result has been validated and approved on that order. The report can be created, it can be PDF'd, and then it can automatically be emailed or posted to a client portal. And there's also the ability to have dashboards where you can really see at a glance the operations in the laboratory, if there are any backlogs, how many samples have been received, how many have been processed for that day. So there's a lot of business intelligence that laboratories can gain from those dashboards. If we take a look at the entire picture, I know this is a kind of a busy slide, there's a lot going on, but you can take a look at the LIMS. It's typically a SQL database. It stands for Structured Query Language. I think Microsoft SQL Server is probably one of the most popular ones, but basically, with having all this data in a central location, it gives you the power to do quite a bit. Not just centralized, standardized reporting, but you can develop dashboards for key performance indicators. When you're accessioning samples, you can quickly generate barcoded labels, and that will allow for traceability throughout the system. You have the ability to generate schedules and scheduled sample sets and create stability projects as shelf life projects. You can import all of your instrument data. You have the ability to store data as a backup in the cloud, integrate with a number of enterprise solutions such as SAP, ERPs, and CRMs. You also have the ability to leverage tablets and mobile technology. So if you're doing any type of field testing, quality checks on the plant floor, where you need a tablet. You can actually import that data directly with 4G, 5G, or Wi-Fi. It also has the ability to store the data on the tablet if you're in a location where there is no signal. There's also the opportunity to integrate with an electronic lab notebook. These are ideal for unstructured data and very popular in the pharmaceutical industry. And then you can also have a client portal attached where clients can not only look up their results 24/7 and download reports, but they can also submit samples to the laboratory through a LIMS kiosk. So it's really a wonderful way of allowing your laboratory to accept samples 24/7. And if you look at these blue arrows, it's really showing all the areas where data integrity is strengthened because the data is transferred electronically and there's no human re-entering of data, rekeying of data, because that's where transcription errors occur. We talked a little about positive ID. This is basically leveraging barcoding, whether it be one-dimensional or two-dimensional, 1D, 2D. Two-dimensional can contain much more information. There's also radio frequency ID, RFID. So there's a lot of different ways to enforce data quality, traceability to ensure that the sample results that you have came from the sample that you analyzed. And again, the advantages are it's much faster, it's much more accurate, and it's much, much more efficient. And it can be used not only at sample accessioning, but it can be used throughout the analysis of the sample as well as sample disposal. Instrument integration is increasingly important. The beauty of instrument integration, again, is that it's fast, it's effective. No one needs to be involved in the transfer of that information. There's a very quick return on investment. It's typically 6 to 8 months, and it can be faster depending on the number of samples that you are actually analyzing. And there's hundreds and hundreds and hundreds of different instrument vendors. And unfortunately, there's no standard. So each instrument puts their data out in a different format. So vendors are always capturing that format and creating a parser to put that format in a file that the LIMS system will recognize so that it can be automatically imported. Dashboards we touched on briefly before. They're very important for looking at key performance indicators. They're not only useful for the management of the laboratory, but also for analysts. If I'm working in one department, I can see what my backlog is. I can see what I've completed. I can see which samples are critical. So it's really nice to have these reminders in the forefront so that you don't have to look for what work is needing your attention. And again, it's all about rapid communication and rapid feedback. So if there's a potential problem, you have early warning to address it. Sensors are playing a very big role in laboratory automation, and they not just laboratory automation, in everything, in cars, in equipment, and they really are the future. Having sensors in your refrigerators, freezers, and incubators, and setting up the key temperature range so that if that range is exceeded, an alert will be sent to your smartphone. You'll get an email alert, and then you'll also get a text message on your phone to let you know, hey, there's a problem. And this is really cheap insurance because not only does it tell you the health of the equipment, it can take readings every 15 seconds and then back up that data to the cloud, but it can also tell you if that equipment is starting to have problems so that you can take action before it's a Friday at 6 o'clock and your refrigerator or freezer decides to die. So it's really powerful and useful. And the other aspect is the thermocouples are NIST certified, so for your ISO audit, you'll be bulletproof, or any audit, because one of the requirements for the laboratory is recording the temperature each day. So this will allow the laboratory to go paperless and be compliant for the audits. Now, when it comes to hosting software, hosting LIMS, there are always options. The two main ones are cloud hosting, having a LIMS on demand solution, or SaaS as it's frequently called, which stands for software as a service, versus on premises. In the old days, everyone had a server in their laboratory. They had IT people that had to manage and maintain the server or servers. Every probably 2 to 3 years, they would replace them. They would have to be responsible for, network switches, all the software that went on that server, antivirus software, backup software, Windows, Citrix if they were deploying their solution to their workers remotely. So there's a lot of challenges to managing an on-premise solution for the laboratory. You are basically responsible for everything, managing and maintaining it, applying updates, monitoring disk space. Applying updates is really critical because that's where that's a vulnerability that hackers could take advantage of. So you want to make sure that you're always on top of that. Today, the cloud has become increasingly popular. Most companies, even IT companies, are moving to cloud technology just because it allows them a lot of flexibility and cost savings. They no longer have to have full-time IT team members managing and maintaining their own hardware. They basically lease the hardware in the cloud. They have IT people leased in the cloud as well that are doing all of the maintenance, the daily backups, the antivirus, the vulnerability testing. That's all done through the hosting partner. So it really frees up the laboratory to focus on their core competency. So we've seen more and more people moving to the cloud in the last 5 years. It really is the future because you can really leverage the cost savings. And there's considerations with the cloud. Do you want a private cloud or do you want a community cloud? So a community is a shared server with multiple virtual machines on it. A private cloud is one that's dedicated to just your organization. Private clouds are typically much more expensive, and then you have to ask if those costs are justified. Oftentimes, it's important to understand where that data is being hosted. Is it being hosted in Ireland, or is it being hosted in the U.S. or somewhere else? Who owns the data? There's some agreements that say that whoever's hosting the data own it, so you have to be very careful and make sure that you always own your data. Also, it's important to ensure that there's a disaster recovery plan in place. So, just because the data is in the cloud and not on your premises, you still have to make sure that there's a plan in place if something does go wrong. How often is the data configuration backed up, and how is it backed up? Are they doing snapshots? Are they doing full backups? What are the integration options when you're in the cloud? If you have SAP or some other ERP solution that you want to integrate, how can you get that data to the cloud? Do they have a file transfer protocol? Do they have a RESTful API? Those are important questions to ask. And then also, how often is the environment monitored? Routinely, annually, never? What type of security do they have in place? So, it's important to make sure you find a dependable cloud provider. And I always tell people, all hosting is not created equal. So it's important to understand where your data is being stored and how it's being managed and maintained. Considerations, instrument integration, we touched on it a little on the last slide, integration with enterprise systems such as SAP, other ERPs, financial packages, making sure that, when you do have instrument software, how are you backing up the raw data on that instrument? Are you backing it up locally? Are you pushing it to the cloud? Oftentimes this data has proprietary software so that it can only be read on that instrument. How will backups of raw data files be managed? There's so many considerations. These are the same considerations if you're managing the data on premises, but oftentimes people think, oh, everything's handled in the cloud, and they really need to understand, well, not everything. If you have raw instrument files, you have to continually back those up, whether it be in the cloud or on premises, but they need to be considered. Integrating with GIS solutions as well as production software and SCADA systems, as well as sensors. In summary, I think it's very important to begin with a strategic vision of where you want your laboratory's data management solution to end up. The role that a LIMS plays with a quality management system, along with all the integrations with not just enterprise systems, but also instrumentation and leveraging sensors throughout the laboratory, really makes sense in terms of maximizing your resources, reducing your cost, and increasing your productivity. Regulatory compliance is becoming increasingly important. The requirements are becoming much more stringent, and without having systems in place to address those, it's going to become increasingly efficient to achieve that certification. So whether you're looking at, growing your organization, increasing efficiency and reducing costs, or meeting compliance goals, LIMS and quality management systems are key. When you're looking at various technologies, make sure you become educated in the pros and cons of each, and also keep the big picture in mind as the system is built out, and keep in mind everything that you can do. And it's not critical to do everything at once. Most of the successful deployments use the phased approach where they have a roadmap and they know what they're going to attack at each phase. With that, I thank you for your time today, and if anyone has any questions, don't hesitate to reach out. Here's my email. Thank you again and have a great day. Bye-bye.